Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, if you look at this, here you've got one thing divided by another thing. As n tends to infinity, this is going, the numerator is just going to get bigger and bigger and bigger. So it's heading towards infinity. As n tends towards infinity, the denominator is also heading towards infinity. So here you've got infinity over infinity, which is an indeterminate form, which means you can apply L'Hopital's rule. So differentiate this, that will then give you this, and then differentiate this, that will then give you this. So when you come to differentiate this, you can think of it as being, let's say y equals 3, 2 to the power of n plus 1. So take the natural log of both sides. So this thing here will come down, so it will be like this, and then natural log of 3. So now use implicit differentiation. So this will be 1 over y dy by dx. You should know how to do this by now. And then you differentiate this. So if you differentiate this, what's here is going to be 2, and then you've got this natural log of 3 here. So now times both sides by y, so dy by dx equals this thing, 2n natural log of 3, and then times y. Remember, y is this thing here, so that will be 3, 2n whatever. So this thing here is this thing up here. So basically, if you differentiate this, it will give you this. Differentiate this, it will then give you this. So now let's check it again. As n tends to infinity, this whole thing here, well, if you look at this here, this is a constant, this is a constant, so this thing here is a constant. But then as n tends to infinity, this n here is just, well, it's going to get bigger and bigger, meaning this bubble here will get bigger and bigger and bigger. So this is heading towards infinity. This is also heading towards infinity. This is an indeterminate form, so we can apply L'Hopital's rule again. So differentiate this, that will then give you this whole thing here. Differentiate this, that will then give you this thing here. So now if you tidy this up, it will give you this. So this is a constant, this is a constant, and you can see that as n tends to infinity, the whole thing here will head towards infinity, and over 10, well, over a constant. So the whole thing is heading towards infinity. Okay. So the sequence diverge. All right. So next one here. Find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, remember natural log of a take away natural log of b. That's the same as natural log of a over b. So make use of this. So basically, it's this divided by this. So rewrite this as this. Rewrite it as this. So now you can see as n tends to infinity, this whole thing here this whole thing here is going to be 1. As n tends to infinity, this whole thing here will be 1. So when you natural log of 1, it's heading towards 0. So the limit here will be 0. Okay. Next one here. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so similar to the previous example, natural log of a, take away natural log of b, that's the same as natural log of a over natural log of b. So we can say this divided by this. So rewrite this whole thing here as rewrite it as this. So now as n tends to infinity, this is, well, you've got this thing heading towards infinity. This thing here is heading towards infinity. As n tends to infinity, we can pretty much ignore these two small insignificant terms. So let's just look at n squared, and then here you've got n squared. So as n tends to infinity, you're going to get, well, this thing here is going to be 1. The limit here, as n tends to infinity, this whole fraction here will head towards 1. So when you natural log of 1, that will be 0. So again, the limit of the sequence will be 0. Okay.